Today I am going to cover this 7 basic QC tools. These are very important to arrive at permanent solutions to quality problems as well as business or organizational problems. These 7 tools look to be overwhelming, but they are not. If you understand from the basics, they are very easy to understand and apply. This is where I would like to add value. The 7 tools are stratification, check sheet, histogram, Pareto analysis, cause and effect diagram, scatter diagram, control charts, and if you are writing global exams, you can memorize them through an acronym S2 C3 HP. S2 stands for stratification and scatter diagram. C3 stands for check sheet, cause and effect diagram and control chart. H stands for histogram and P stands for Pareto analysis. This is how you can remember. Now let us start with the stratification. Stratification says split given data into different categories. For example, if I have sales figure for all over India, split them into North zone, South zone, East zone, West zone. Now we'll be able to see better which area I have not done well in my sales and focus my improvement actions, marketing strategies there to improve my sales. This is as simple as that. Stratification can be done machine-wise. For example, I have 200 machine breakdown happening last year in my department. Now machine-wise, I categorize them, stratify them, and then understand which machine is failing the most and put my resources to improve that machine. It can be operator-wise, which operator is doing the best, which operator needs training, shift-wise, which shift is doing the best, which shift needs more resources to improve, and types of defects. For example, if I have 4 or 5 defects in a mobile phone, for example, the uneven brightness of the screen, scratch on the body, button not working, bright spot on the screen, and so on. Which complaint is coming maximum from the customer? I can categorize and then focus my resources to solve them and with the priority. Why do we need to prioritize? As you can visualize, no company will have enough resources to solve all the problems, which may be very small problems also. So identify the most important problems and then put your resources behind that for higher gain, because there is a proverb in management: higher the pain, higher the gain. So this we understood. You use the data here because the best decision is always the data-based decision, not the perception-based decision. Now this is an example that I can give here, real example. The total number of breakdowns of 4 machines in a year happened to be 189 for one of the departments, and the department head started getting panicky. So then he used the stratification tool. He used the below table to segregate the failures or breakdowns into machine wise. So as you can see, machine 1 failed 56 times, 2 39 times, 3 35 times, and 4 59 times. Now for prioritization, obviously the priority number 1 will be machine number 4, priority number 2 will be machine number 2 because machine number 2 has 56 failures, and so. Now I'll come to the second tool, that is check sheet. Here data is gathered over a period of time, say 1 month, 1 year, and captured category wise mostly as the event happens. For example, if I am manufacturing, say, TV, in TV, I may be having 3 models. Now, within 3 models, failures can happen for different reasons, like the component failure, monitor failure, or remote failure, command failure, and so on. In such an event, what I can do is I can ask my marketing man to capture the defect data as the customer complaint comes and mention in a XY chart, which I will show in the next slide, called as the check sheet. As the type of defect is seen by the marketing person through customer complaint, he keeps on noting down. Over a period of 1 month or say 6 months, I will be able to compile them and see which failure is the most dangerous one, most expensive one, which needs to be immediately attended to. So this is the benefit of check sheet. As the event happens, it is captured over a period of time, and then data is useful in arriving at your strategy for input. This is the example I was talking about, a company that say manufacturing 3 models of television, 1013, 1017 and 1018. You can see different failures happening there, like IC failure, capacitor failure, command failure, transformer failure, and so on. Now, as the customer complaint came, they entered one line means one complaint from the customer for a period of say 1 month. Now, if you look at this table, you find for model 1013, 1017 and 1018 means all the three models, capacitor failure has been a predominant failure, and this becomes my first priority to solve, say by going for a higher reliability capacitor instead of the capacitor I am using now. Now, interesting thing happens. In model 1017 alone, the command related failure is very high. That means remote command related improvement I need to do for model 1017 only. Please remember this. If I do the same improvement by spending more money on 1013 and 1018, it is unwarranted improvement, loss of money for the company. So now you understood how check sheet can be very useful since the data is gathered as the event happened over a period of time, and it helps you to prioritize your improvement required. Now we'll come to histogram. Once you talk about histogram, we see tall pillars side by side aligned on a XY plot. That's why it's called as a bar chart. Here, class intervals are chosen on the x-axis. It's a high sounding word, but it is simple. Means to say, if I have to measure 0 to 100, I can split them into 10 categories. 0 to 10, 10 to 20, at the end 90 to 10, 100 and so on. So, this plot is useful in understanding the health of the process. For example, as I told you, 0 to 100 is the measurement. They have been split into 10 categories, 0 to 10, 10 to 20. These are called as class intervals of equal width, 9 up to 90 to 100. How many times those intervals happened during the measurements has been noted down in the second column as a frequency of occurrence. Since 40 to 50 being the center of the process, the occurrence there will be high, that is 19 here. For a good process, it goes on decreasing as we move towards the upper specification limit on the right side or on the higher side, or lower specification limit on the left side in the plot or towards the lower side here. This is the plot here. Since the peak of the pillar is actually aligning with the target, this is a good process. And if you compare with the tallest pillar on the right and the left, you see that they are symmetric. The plots are symmetric. That means it is a good process. But there is a problem that the spread is too wide because so many pillars are aligned side by side. If the spread is too wide, there will be defect beyond 9 and 8, as you can see here, and those defects can be eliminated only by reducing the variation. Means there should be less number of pillars side by side. The pillars should be the tallest pillars. So this is how you can visualize the condition of the process using the histo. Now, if the process is not good, how to identify? Instead of being symmetric, as I showed you in the previous slide, here you see this skewness, means there are tails. If the tail in the distribution of pillars is towards the left, it is left skewed. Means there is a bigger threat that the items will get rejected on the lower specification side, given the tolerance for the, and if the tail is on the right side, the parts get rejected on the right side, that is on the higher specification side. There are more dangerous cases. See in this case, in the figure on the left, there are two peaks. Means to say the process is having lack of continuity, which is very dangerous. A good process should have single peak only. Also in the second picture, you see one set of pillars on the left side. Away from that, the second set of pillars. That means there are outliers. This is also an example of a very bad process. You see now how histogram helps you to quickly understand the health of the process, because process is the cause for a good product or the service, and if the process is bad, permanent bad output is going to happen, and if the process is good, you will get a good product or service permanently. Now I come to the fourth tool called the Pareto analysis. Here you can see an XY plot here. On the x-axis you have mentioned the types of defects. Say this is a billing defect case, just to give an example how administrative problems can also be solved. Here, the first is a no purchase order and second is wrong purchase order being given. These are vital few which have to be attended. How did I arrive at this? Let us get into the background. Pareto chart was devised by Wilfred Pareto, a financial analyst who found 80% of the wealth was found with the 20% of the people. He extended it to other areas also, hence it is called as 80-20 rule. Now here, the types of defects are arranged in the Excel sheet in descending order of occurrence, as you can see here, and they are plotted on the Excel sheet. Y-axis is nothing but number of occurrences. For example, the leftmost, that is parameter, or the failure reason, that is no PO. The occurrence is around say 270. So like this, individual happenings have been plotted, and also the cumulative figures are taken for them and they are actually marked on the right extreme y axis, which is from 0 to 100 since it is calculated in percentage. And here on the right side, if you go over to 80%, draw a horizontal line and drop down here, all the parameters here to the left of this line are vital few. Here there are two parameters out of 6, namely no PO and wrong PO. These are the vital few, only 2 reasons out of 6. If you attend, you can improve your efficiency by another 80%. It's a huge takeaway from a Pareto analysis to identify the vital few and then come out with the permanent solution. With simple and time-saving approach, you can arrive at permanent solution. This is the great tool. Next, we will go over to cause and effect diagram. Cause and effect diagram is one of the diagrams where you do not use statistics mostly. To some extent, you may use if you have the data. Otherwise, you use your process knowledge, and it does not carry any numbers on the plot. Now, cause and effect diagram was devised by Ishikawa, and it's also called as Ishikawa diagram. It's also called as fishbone diagram or cause and effect diagram, as we have mentioned. The detailed cause and effect diagram is drawn here. The center line represents the main bone of the fish. The head of the fish is nothing but the problem statement, and the main causes are listed here: machine, tools, QC training not being given, process, design, inspection, and operations. Now let me take one case here: machine. Under machine, you have seen now condition of machine is a reason, wear out of the machine is a reason, and so on. Like this, as you can see here, there are 35 reasons for failures could be listed in one picture, and one picture is 1,000 word worth. So here you find quickly the main causes, major causes, and you can come out with the permanent solutions without any hassle. That's the takeaway from a cause and effect. Next comes the scatter diagram. Here you take 2 parameters of interest. For example, if I am using petrols of different companies at different times and checking the mileage in my car, output being mileage, mileage is plotted on the y-axis, input being types of petrols, it is marked on the x-axis. Visualize. This becomes now a scatter diagram. Now I can understand from type of petrol to mileage, is there a relationship, correlation we call it as. Whether in which company's petrol I am getting the maximum mileage, if there is any difference in the mileage. All these analysis can be possible through a diagram called as a scatter diagram. How to draw is given here. Maybe I will explain all this in detail when I take this as a separate detailed chapter. Now, to understand the scatter diagram, I have taken one example here: elongation of a product, rubber product, versus the moisture in the rubber content. A experiment was drawn, and the results were tabulated and they were plotted in a scatter diagram. Output being elongation, it is put on the y-axis. Input being moisture content level, it is put on the x-axis. You find that as the moisture content is increased, elongation increases. Now the conclusion is there is a strong correlation between moisture and elongation. So if you want reduced elongation, you should reduce the moisture content in the rubber. So this is how scatter diagram helps you to understand the relationship and then improve the inputs so that output is at your desired level. Now there are 3 cases possible. In the first case, the output is varying haphazardly irrespective of whether you increase the input. Means there is no correlation, no relationship between input and output. Now coming to figure number 2, as the input is increased, output also increases. Means there is a positive correlation. In the third plot, you see that as the input x increases, the output y decreases. That means there is a negative correlation. This is how you can understand the relationship between input and the output, and between two inputs also sometimes, and optimize the input so that you get the desired output. Next, the last one is control chart. Please remember, control chart is meant to be drawn for critical parameters only where you are struggling to achieve them. One product can have more than one control chart, depends on how many critical parameters are there in that particular product. Control chart is a line graph. Here, the average of the reading becomes the central line. Means to say, if you have inspected 100 parts, their average value is the central line. Now, depending on the process variation, the measure of which is standard deviation, if you add 3 times standard deviation to this, you get the upper control limit. And if you deduct 3 times the standard deviation from this, you get the lower control limit. Now, as you plot the readings for the 100 numbers you have inspected, they get distributed randomly. And for a good process, the values you plot should be below the upper control limit and above the lower control limit and closer to the average line to the best extent possible. If by any reason any data value goes outside, means above the upper control limit or goes below the lower control limit, means to say there is a special reason for failure which has to be studied and solved. If that is done, the problem gets solved permanently and the process becomes more capable and you can have full confidence on the process. One of the takeaways I experienced was I was asked by my customer, overseas customer, to plot the control chart for a period of 1 year. I emailed this to the customer overseas. Within 2 minutes, they were able to get assurance that my process was good and process was fully under control. Look at the benefit. As a process in charge, you can also decide the health of the process in 2 minutes based on the performance over the entire 1 year or even more. This is the kind of takeaway from this. This is the basic input to get a feel of these 7 tools. I really want detailed inputs on each of these tools way forward. I take this opportunity to thank you for your support. Please subscribe to this channel if you have not subscribed so